Hey everyone, welcome to this episode of Coffee with Cosmos DB series. So we are at the 13th episode of this series. And if you have missed to join our last episode, you can watch the recording in the playlist. If you're joining this session for the first time, this series is all about spreading the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share the URL with the community members who are looking to learn more about Cosmos DB. If you're interested to present or have any feedback, please reach out to us. And thanks for all the support so far. I have seen that this community is rapidly increasing on a daily basis. Please show your love by subscribing the channel. With that, let me introduce our guest for today. He's not new to us. He has been in the show earlier, and also this is the second time in the series. In fact, he did the first episode with us. Welcome again, Sandeep.
My pleasure, Saji. Nice to be here.
Yep. I don't think you need an intro, but those who are watching or like for the first time, you can do a bit of introduction.
Sure, thank you. So I'm Sandeep. I'm a program manager in the Azure Cosmos DB team. Have been here for about a year plus now. I take care of supporting big customers that we have, and I also take care of um, a little bit of in the Mongo migration space. And then I've also been working with OpenAI and Cosmos DB, and that's what we talk today: how to use Cosmos DB and OpenAI together in your own project.
Yeah, I think today's topic is going to be super interesting, as well as you know, we know that we are in the mid of massive platform shift, that is the generative AI. You might have heard many times about OpenAI and how it's transforming the life of every individuals. Today, I think Sandeep will talk about how to build applications combining the capabilities of Azure Cosmos DB with OpenAI. Yeah, over to you, Sandeep.
Thanks, Ajay. So yeah, so this session basically what I want to focus here is on how we can build your application using your data, and that's key here, and that's why I highlighted that in the title. And when I say your data, I mean data that is private to you. It could be your proprietary data. It is domain specific knowledge. It is not the regular data that OpenAI has scraped from the internet and built its large language model. So what we are going to use here is data coming from your database, and in this case, it's going to be a NoSQL Cosmos DB database. But it is going to use the large language model capabilities that OpenAI has. So you're going to use the natural language of interacting with the model, but it's not going to use its own data store. It's going to use your data store. So the data is always going to be in line with what you have provided. Second thing, you don't have to worry about your data being leaked out because we are not sending your data um, to the OpenAI service for or the the I would want to call it the public OpenAI service. You're going to use it in your own tenant, and because you're going to use it in your own tenant, the data will be inside your subscription and it will never go out, right? So let's not waste too much time. Let's get into the presentation. So this is a simple application, the way we have all been building applications for a long time now. Um, and there are just 4 steps to it. There's a user. The user provides some input to a console. Now this, I'm calling it structured input because this could be a command that you run on a terminal. This could be a web form. This could be a Windows form. This could be a mobile app. Whatever may be the case, you are providing data in a structured way. The developer who created the app has asked you to provide data in a certain way. It could be in the form of buttons, maybe commands, but your data is given in a very structured format. Now, this structured data is in turn you converted by your application to a query. It could be a SQL query. So, and then that query is executed on a database. The database returns a result set, and that data is then painted as a report. It could be a report again, like a report as a dashboard. It could be a web UI. It could be a form or anything, right? So it's all structured. You are starting from so the user was supposed to learn how to use your system. So they'll provide a structured input, and they get a structured output. So that's how our regular applications look like. With the coming of large language models and OpenAI, things have changed. Things have changed in the sense now it's all natural language. You're interacting with it in natural language. So the flow has changed a little bit. You now again the user provides an input. Now the instead of providing input in a structured format, the user can provide data in a natural language. And when I say natural language, we're talking about, let's say English. You're talking to the application in English. It could be any other language also, but let's just take English as an example here. So you are asking the application to do something, and in return, what you're getting is a completion, which is again in natural language. So you are conversing with the application. It's like a conversation. It's like on the other side, there is as if there is a human being and you're talking to that human being in your language, right? So, but how did it happen? So the way that this happens is once a user provides his natural language input, we convert that input into what we call embeddings, which is nothing but a vectorized format of what the user provide. And when I say vector, it is basically converting it into a matrix of numbers. So there are algorithms that will take your text and convert it into a vector, and that vector is called an embedding. We take that embedding and then search it on a database to get the list of records that match this query. This data that you query is then provided to the large language model like OpenAI service, which then uses that data, the data that you provided from here, from the blue box, and provides a response based on that. So I will go into detail about this. Now, I just want to highlight one part in this slide. So there could be two cases. You could be an application developer who already has an existing application, which is having its own database, and you want to improve it. You want to add natural language capabilities into it, or you could be developing net new. If you are augmenting an existing app, then what you can do is on top of your existing database, you can use a vector DB to augment the vector search capability. If you are actually building an app net new, then you could have this whole blue box in one database, and it could be just the vector database. You don't need to have two databases in that case. So for example, in the case of Cosmos DB, if you're using Cosmos DB NoSQL, because we do not have a vector search capability NoSQL today, we are going to use Azure Cognitive Search as our vector database. But if you are using Cosmos DB Mongo vCore as your database, then we have vector search capabilities built in. So in that case, you don't require these two databases. You could have just used one database. So just to repeat, you give the user input, convert it into a vector. That vector generates and is stored. We search that vector in our database, in our repository. We get a list of records that are somehow connected with what the user provided as input. We take those records and provide it to the natural language model along with our prompts. And when I say prompts, I mean that instructions. So here we provide, when we talk about regular applications, we decide how the response should come using queries, using UI, etc. Here we are going to give the instructions also in natural language. So when I say that, I mean, for example, you may give instructions that I want it to be designed for a novice user. I want it to be presented as bullets. I want you, or you can tell the natural language model, behave as if you are an AI bot, or behave as if you are a sales agent. Behave as if you are a telecaller, right? So depending on what instructions you provide, the natural language model is going to give an appropriate response. So you give your instructions, you give your data, and you again return back the same query that the user provided. The large language model will utilize these three inputs and then process it and give you a response. And again, it will be in a natural language format. So it is in the form of a conversation. So you can now, this is a very basic construct on how natural language conversation happens with LLM. Now you can take this example and build many scenarios out of it by using many permutations and combinations. So
Sandeep, sorry to interrupt. There is a question
sure.
asking what is rack pattern. Can you explain in detail?
Yeah. So RAG pattern basically is just concept wise, it says that you are getting data from your data source and augmenting the data along with your prompt to the large language model, right? So when you do that, what happens is the large language model is then able to use your data and provide a response. And RAG stands for, I forgot the full form. I'm just searching. Sorry for that. It's retrieval augmented generation. So basically, you retrieve the data and then you provide the data to LLM, and then LLM uses that to generate the response. So RAG
Okay.
basically starts with augmented generation.
Thank you. Yep.
Okay, so now that we have the concept here, let's just see this in action. Let's see a small application that I have developed in action, and then I will go through the code. I'll explain the concepts here. Basically, the same concepts, but I'll take you through steps on how we do that, and you will see that it's so simple to do. Okay. Okay, so I have this application. Let me just run this, and then let me show you how it works. So yeah, I'm running it in. So this is the application. 1 second. Okay, so this application is a recipe application. What we are saying here is we have some recipes that we have stored in the form of JSON files. And let me show you some of those recipes here. So if I go to the Solution Explorer, oh, sorry, let me just. So here I have got many recipes which are nothing but JSON files. I have and this is something that I just copied from the internet and stored them. So in my case, my proprietary data or my data, the way I called it in the title, is these recipes, right? So we are going to use these 13 files that we have, and the language model is going to use these 13 files to provide all the response. It's not going to use any data from outside. So I have got these 13 files on my local machine right now. And first thing that I want to do is I want to upload this data to a database and populate my database. So here I have my Cosmos DB database. It's empty right now. There's no data here. So I'm going to use the first option in my application and uploading the documents. So it's going to upload the documents, and now you can see it says that it has uploaded 13 documents, and all 13 of them are not vectorized. So let's go to Cosmos DB and see what happened here. So you will see those 13 documents showing up here. And again, it's the same JSON that I showed you in my sorry. Yeah, so the same 13 documents, same JSON file that I showed you there. Nothing has changed. Standard Cosmos DB data has been uploaded. Now, the next step that I want to do is I want to vectorize this. So the reason why we need to vectorize data here is we want to see, we are going to converse with the application in natural language. If I have got tons of data, let's say I have, instead of 13 records in my database, I have got 100,000 recipes in my database. When a user goes and types in something of what he wants to cook, he or she can make many mistakes. There could be spelling mistakes. They could no, they could phrase their question in a way that it is not an exact keyword search with your what is stored in a database. So what we are doing by vectorizing is, when I vectorize something, I am able to do a search of proximity. So what I'm going to do is I'm going to convert my data in Cosmos DB into vectors. I'll show you what a vector looks like. So I'm doing that. At this point, it's fetching the recipes, it's vectorizing each recipe one at a time, and then it will upload that response back to Cosmos DB. Okay, so it's vectorized. Now let me go back to Cosmos DB and open the same document once again. So as you see here, it has added this array of floating points, which is the vector that it has generated. Now this vector, what I can do with this vector is I can search on this vector using another vector. So just like when you say I am doing a like operator in SQL, you can similarly do a vector search here. And in a vector search, what it does is it goes and finds the closest items. So if something is, for example, is called, let's say, coffee, and I type in, let's say, Java, the system may be able to find that the Java and coffee are similar because Java is a type of coffee bean, right? So when we use vectors, we are not limited by the exact keyword, but we get a much wider way of searching, and that is by proximity, right? So now, of course, how the vector search works and what are the logic used, that's beyond the scope of this presentation. And there are many vector search databases. In our case, we are going to use Azure Cognitive Search as our vector search, right? So now I have created vectors for each document. They are stored here. I have also in parallel uploaded these vectors to Azure
Sandeep, I
Cognitive.
have a question. How did you like vectorize those JSON
Yes,
format?
yes, I'll talk about that. So if I go to my code and I'll just show that. So when I use my OpenAI service, in OpenAI service, there are two embedding service. So if you see here, OpenAI. So you provide a JSON to the OpenAI service, and it will give you a vector as response.
Okay, got it.
So I took that. So for each document, I passed it to OpenAI. I got it converted to a vector, which is here, and then I used this data and I stored it in my Cosmos DB. I also, in parallel, uploaded this vector to Azure Cognitive Search, because that is where I'm going to do my search operations, right? So at this stage, I have got 13 documents that are there in Cosmos DB. All of them are vectorized, and they also reside in Azure Cognitive Search. Now, next step is how to now using the application. So my database is ready for now taking questions from the customer. So let's say I'm going to ask something, right? So let's say today is a cold day and I want to feel warm, I want to drink something warm. So let's say I want to have something hot. So remember, I am not giving any recipe name, I'm just saying I just want something hot. And what it did is that if you see the screen again, or you see the screen closely, when I said something hot, it found some recipes and it listed them, and then the large language model got confused because there are multiple recipes that were hot. So it is saying that what are you looking for, a hot beverage or a hot meal, right? Because I didn't say what I'm looking for, right? So now if I change my query and I say hot drink, let's see what happens. So if you see here, it is saying processing chai, Irish coffee, etc. So here, now it has changed the response and says, do you want a chai tea or an Irish coffee? So that way I can further search for it. Of course, as a simple query, if I type in chai tea here, it's going to get that for me, but that's the simplest option. But what I want to show you once this response is over, how you could use the same data to generate interesting responses. So this option of chai, tea, Irish coffee, and all this has come from your vector search. So because I typed chai tea, it generated a vector for chai tea. It searched for that vector in our database. It got a few documents that meant though that those were close to the chai tea vector, and it got those data. I processed all those documents and gave it to OpenAI, and then OpenAI, based on what I had typed in, figured out that I'm actually interested in chai tea and generated this response for me, right? So now this is simple. Now let's complicate it a little bit, and let's say I want to ask, can I cook chai in uh, so it's not just about uh, getting a recipe. I can also ask a question. So it's going to use that data and it's going to come back with some response, right? Or let's say one more question. So just because I use chicken, it says it found that butter chicken is a option, and then it's going to process it, and then the OpenAI service is going to figure out what is the right documents to use and how to generate a response. So here, if you see that it's generated response, no, you don't boil the chicken in butter chicken. Now, let's say I want to further uh, ask the same question. Now, I don't have pepper chicken as a recipe in my database. So let's see what happens. Oh, so looks like the instructions were not followed, and my large language model actually went and searched the internet. So this is something that we need to work on. We need to further improve the instructions. So looks like my instructions are not good enough, and in certain cases, the large language model is actually going and searching the internet also. So this is one place where we need to test it. We need to further work on it and make sure that the responses are always grounded to what data you provide, right? So this is just and again, there's no easy way to do it. You just have to keep trying and see how it works, because it all depends on the instructions you provide and how well the LLM is able to use it. So maybe if I ask the question differently, it may not have gone and done it, but in this particular case, it went and searched the internet also. So that's the application that I wanted to show. And now I wanted to show you how this whole thing works. So
Before that, Sandeep, there are a couple of questions on the chat.
sure.
One is, can we use any other service other than OpenAI to vectorize the JSON documents?
Uh, I'm sure, yes, you can, because what we generate is a vector, but we don't know the quality of. So every service may have a different quality of vector that they generate. I have only tested with the OpenAI vector service. I'm sure there are other vector generators and vector search databases. So you will have to try and see how effective they are.
Got it. Okay. And there is another question whether Mongo vCore or Cognitive Service support images as vector search?
Uh, I'm not sure, but I think as once you convert it into a vector, it should not matter whether it was an image or a
Yep,
text, because it's just a vector. So yeah, so it's all about how you convert things to a vector. If once you have converted it to a vector, it should not matter.
got it. Okay, thank you. I think those were the questions we had on the chat.
Sure. So in this application, I just want to show that we are using three SDKs. We are using the OpenAI SDK here. We are using the Azure Cognitive Search SDK, and of course, we are using the Azure Cosmos DB NoSQL SDK. And what are we doing and how are we doing it? So what we are doing here is, let's go one by one. I go start with Cosmos DB because that's the simplest. Uh, there is no special OpenAI related stuff that I have done in Cosmos DB. It is a very simple class. It does some queries to get data. It uploads data. So we are writing using bulk writer. We are writing documents to the container. We are getting data and updating documents based on once the embedding data is done, and that we are doing using the patch API. So basically, get, insert, and update. Just three operations of Cosmos DB that has been used here. Nothing, no specific additional activity on Cosmos DB side. On the OpenAI side, so this is the instructions that I am passing to the application. Okay, so if you see here, I've said don't suggest any recipe not provided below. Now looks like this instruction was not taken seriously by the LLM, so I need to fix this. I may have to write this in a different way. And then I have to try it and see if it makes sure that it doesn't read anything outside the JSON files here, right? So I will have to try this. But essentially, if you see, these instructions tell you, it's telling that you are an intelligent assistant, you are designed to provide helpful answers, your responses should be complete. So these are my instructions. So instead of writing my English language instructions, instead of providing code to figure out what should be the response, I provide all of it in English language. So this is the part that I was talking about, instructions in natural language. So here, this I will be using when I am generating the completion, and I'll reach there. So what we are doing here is we are initiating the OpenAI service. In the OpenAI service, there are two endpoints. One's called the embedding endpoint. We are using the embedding endpoint to generate the vectors. So whenever I need to generate a vector, I provided the data, a JSON file, and it takes the data, calls this embedding API, and what I get in response is a vector array or the embedding here, right? So that's one part. Second part I am doing here is get chat completion. So when I say get chat completion, it basically means we are all conversing with the OpenAI service. So I provide the OpenAI service with some prompt, and in response, it gives me a response. So when I say a prompt, you see that I'm generating a prompt, and that has got the three things. One is the system prompt. This is what I showed you on the top. This is what this instructions plus documents. These are the documents that I found from Cosmos DB, and I'm giving it to it as a form of string. And apart from that, I am providing it for the user role, whatever user typed in the console. So I am providing three inputs to my OpenAI service. Two of them are in the system role, and one of them in the user role. So the AI service is going to use these instructions on this document and process this user query, and at the end, it's going to give me a response. And that response is what we are painting on the screen. And when I'm not displaying these, but for every response we get, we also see how many tokens were used, because in the OpenAI service, everything is measured through tokens. So depending on what model you use, each model has got the limitation on number of tokens that are available for a response. So if your data is too large, if you provide it a large number, let's say you provide it in my case, I'm providing not more than 10 documents at a time. But let's say instead of this, I query the whole database and provided a list of 1,000 documents or 100,000 documents. Then OpenAI service is going to throttle you and say that there are not enough tokens to process your request. So this is important information for you to measure as to how much tokens are you consuming during your OpenAI interaction. So last but not least, I will just also show you how the cognitive search thing works. Again, in the cognitive search, what we are doing is we are building an index. So whenever we create a cognitive search, we first build an index, and we have an index definition here. We use this index definition to create that index, and that's we are providing that we want to provide a vector search, and we are providing that we want to do a vector search on this embedding field. So we create an index on the cognitive search. Next, we use the upload function to upload the documents to cognitive search. So once we have created the the index and uploaded the document to cognitive search, we are able to use the vector search functionality of cognitive search. And when you do that, it gives us the documents that have been stored in cognitive search, which are a match or which are closest to the vector that I provided as input. So in this case, I can say how many documents I want to say. In this case, I have set it at 5. So if you want to say I want to search more documents, again, depends on how much tokens. So if your documents are big, then you can have more number of documents being supplied. But if your documents are large, then the number of documents that you can supply to OpenAI will reduce. So you have to measure the amount of tokens that you use. So you can fine tune it by changing the count here. And by doing this, what I do is when I pass this vector, it searches the cognitive search database. It returns me a few documents that may be close to the vector that I provided. That doesn't necessarily mean that those documents are matching with my query. It is just saying these documents are close to whatever query that the user has provided. Now, once I get these documents, I actually go to Cosmos DB, get those documents from Cosmos DB based on the IDs here, and then I take that documents and give it to Azure OpenAI service here and pass it as documents here. So all three services are coming into play. First, Azure Cognitive Search to do the vector search, 2, Cosmos DB NoSQL to get the documents, and 3, to OpenAI service to actually do the completion. Now, if you are using a MongoDB vCore or a vector database, then the first 2 steps could have been combined and you could have done it in a single step. You didn't have to do it in 2 steps. But in my case, because I was using NoSQL and I'm augmenting the language, the natural language capabilities into it, I am using Azure Cognitive Search as an added capability. So I guess that's primarily the application that I have. So if I can take any other questions if you have.
Yeah, thanks, Sandeep. I don't see any questions on the chat, but I have a question, right? Out of
Sure.
curiosity, like when you said MongoDB could support vector search, but NoSQL API doesn't have, right? When customers are implementing this, what is the cost and also the latency associated with it? I mean, since it involves multiple services, you mentioned.
No, you don't. You will. So whenever we're talking about OpenAI services, especially chat completion, they never happen anyway in split second. It takes the model takes some time to process it, and the time that you spend additional for the vector search is a very, very small percentage of it. It is technically something that you will not even see. So when you're dealing with this kind of implementation, the latency will not be a big factor for you.
Okay.
What you need to focus on is the accuracy, on grounding it, on making sure that the responses are coming correctly as per your requirement, etc. So you need to work on your prompt engineering to make sure that the prompts are appropriate. You are not giving it too much or too little document so that it's not getting you the response. So you will have to, those are the focus areas. Latency may not be your primary focus area.
Okay, got it. What about the cost? Because you mentioned we would be invoking the cognitive service, right? I know
Yes.
that cognitive service charges a lot when it comes to
Yes.
the number of
So
users.
it is expensive. So it's OpenAI service. These are expensive services to run. So for example, what I have done in my code just for that optimization is, so if I look at my recipe class, it has got all these objects here, right? Uh, I created a separate document called cog search doc, which was a subset of those, purely to limit the amount of documents that I'm sending to cognitive search, because I don't want to send everything to cognitive. Essentially, I just need ID and embedding, just two attributes to be sent to cognitive search. I just kept these two things for later to do some more experiments. But by reducing the amount of data that I'm sending to cognitive search, I'm reducing the bill that I have. So you can look at just send whatever minimum you want to send to cognitive search so that your bill on cognitive search is reduced.
Got it. Okay. Yeah, thanks a
And
lot for the.
of course,
Yeah,
if you are using vCore Mongo, then you don't have to worry about that problem. You can
that's
do
true.
everything inside vCore. So yeah, of course, that's an added advantage to it. But again, uh, if somebody has already an application and they want to augment it, then vCore may not be a solution, because that's anyway going to be an additional cost, right?
Yeah, yeah. Yeah, I think we are on time. Thanks a lot for the wonderful session with the demo and also with a lot of questions. Thanks, Sandeep. Thanks for joining. And those who have asked those questions, thanks. And thanks
Thanks.
for those who have joined as well. We would see again in couple of weeks with actually in another week with another interesting session. Thanks, Sandeep, again for joining us. Have a
Thank
good day,
you.
everyone.
Thank you.
Bye.
Bye bye. Have a great day.